Okay, good morning. Unit 9, classwork 11, volume. So we're going to talk about similar volumes. So recall similar figures, surface area and volume ratios. So the question is, which cylinder is similar to cylinder A? Show all work. Well, recall the scale factor is the ratio of corresponding sides of similar figures. That number corresponds to R, the ratio of corresponding perimeters. We're going to have the R squared is the ratio of corresponding areas, and we're going to have R cubed, the ratio of similar volumes. But we also have a surface area ratio, which is also going to be R squared. That sounds confusing. Here we go. Which cylinder is similar to cylinder A? So is it A and B? Well, what do? We set up ratios of corresponding sides and see if they're proportional. So radius to radius. Is that equal to height to height? When I do my cross product, oops, that's not a 5, that's a 3. When I do my cross product, 18 does not equal 20. So A and B are not similar. So let's check A and C. Radius to radius. Height to height. This time it's a 5. Doing the cross product, we see that 30 equals 30. So we know that A is similar to C. Same scale factor, lengths are proportional. The cones are similar. Let's find the missing slant height. So what do? We set up a ratio of corresponding sides. So we'll go slant height over slant height. We'll do 13 over L. Does that equal 5 over 7? Well, if they're similar, they will. So we can just do cross product to find the missing value. We'll do 5 times L equals 7 times 13, divide both sides by 5. So 5L equals 91, which means L is 18.2 yards. These prisms are similar. Find the missing length and width. So what do we have both of? We have both heights. So it's going to be 20 over 8 equals, let's do width first, 8 over W. So we have 20W equals 64, which means W is going to equal 3.2. And again, we can use that same ratio. 20 over 8, height over height equals length over length. 11 over L, cross product, 20L equals 88, which means the length is 4.4. Surface areas of similar solids. If two solids are similar, then the ratio of their surface areas is equal to the square of the ratio of their corresponding linear measurements. So again, area over area, if we're talking 2D, surface area over surface area if it's a three-dimensional shape. But again, A over B squared is just our R squared. These pyramids are similar. What is the surface area of pyramid A? So notice, are we getting bigger or are we getting smaller? If we want the surface area of A, we want to get smaller. So we want the ratio of the heights. So scale factor here is 6 over 10 or 3/5. That's what R equals. R equals 3/5. Since we're talking about surface area, you need to square those. That's not equal to. So R squared is 3/5 squared, which equals 9/25. So we take this, our scale factor, and we multiply it by our surface area. So our new surface area of the smaller is going to be 600 times 9/25. That's how we make it smaller. The new surface area is 216 feet squared. And the same idea, we can do that with volumes of solids. If two solids are similar, then the ratio of their volumes is equal to the cube of the ratio of their corresponding linear measurements. So again, we can take that scale factor and cube it. Volume over volume is R cubed. So we want to find the volume of the red solid in each. Looking at the first two cones, it looks like we want to get smaller. So we want the smaller ratio. Remember, more than one, it gets bigger. Equal to one, it stays the same. And less than one, it gets smaller because we're multiplying, remember? All right, so our scale factor here is 5/12. And remember, that's what R equals. R is 5/12. We want R cubed. So R cubed is just 5/12 cubed. So our volume is going to be that 288 times the ratio 5/12 cubed. And that's going to give us a volume of 20.83 centimeters cubed. Here we're getting bigger. So we can either do 3/4 or 4/3. Our scale factor is 4/3. If R also equals 4/3, then R cubed is 4/3 cubed. Volume equals 9 times 4/3 cubed. Plugging it into the calculator, the volume is 21.33 inches cubed. So we have a couple more to try. Find the surface area of the red solid. Looks like we are getting bigger. Scale factor is 6/4, not 4/6, which is 3/2. Since we're looking for surface area, we're looking for R squared. So R squared is that 3/2, 3/2 squared. We're going to take our surface area of 336 and multiply it by the scale factor, the area scale factor. And our new surface area of the red one is going to be 756 meters squared. And we want to find the volume. We know the radius of both. It looks like we're getting bigger again. So our scale factor is 12 over 10, which equals 6 over 5. Our volume ratio is 6 over 5 cubed. We just take our volume of 7,850 and multiply it by 6 over 5 cubed to get our new volume for the red solid, 13,564.8082.